Hello everyone, this is Hossein Javadi speaking from Universidad Politécnica de Valencia, Spain. I'm going to present submodule 1.6, which is monitoring and maintenance procedures for system performance. About monitoring, so the data collection to evaluate the system performance represents monitoring. And what is the objective? The objective in monitoring is like evaluation of efficiency and detect malfunctions early. So it is recommended to continuously monitor the following parameters. So these two parameters are supply and return temperatures of the ground heat exchanger, and the next one is supply and return temperatures of internal circuit. On the right side, this is one of the screenshot of the system performance. We are using the company which is named Energesis in Spain, in Valencia, and you can see we are monitoring the system by different parameters in kilowatt hour, kilowatt, and temperature in centigrade, Celsius. And on the bottom side of the presentation, you can see the box which is showing two different parameters, which is called SCOP and SEER. So what's the difference? The division of heat release to the building by electrical consumption of the heat pump in kilowatt hour is for winter. So it is heating mode. And the next one is for summer, which is the division of heat extracted from the building in kilowatt hour by electrical consumption of the heat pump. So the acronym comes from the seasonal coefficient of performance for heating efficiency and seasonal energy efficiency ratio for cooling efficiency. So with these equations, you can determine the heat pump efficiency in different modes. On the left figure is one of the examples of different SCOP for the different systems you have. For example, we have SCOP1, which is including heat pump, the SCOP2, which is include also the pump and the fan. And SCOP number 3 is including also the ambience, buildings, fans, and pumps. So on the left bottom side, you can see different indications of these parameters, energy supply to the building, which is showing by Q index of S. We have showing energy coming from the renewable source with different indexes, the energy consumed by the heat pump, and other auxiliary elements like fan and pumps. So if you want to evaluate the system just instantly, we are calling them with different formula like COP instead of seasonal one. This one is like the condenser release thermal power in kilowatts divided by compressor electrical power. So, and the other one is WER, evaporator absorbed cooling power divided by compressor electrical power. So these were for the instant evaluation of the systems. On the right figure, you can see the location of the different volumeter and also the temperature sensors inside the equipment room, and also for the ambient temperature, and also for the boiler heat exchanger, the ground temperature sensor location, and there are some explanation, as you can see as a caption, to explain what are these temperature sensors. Here on the left picture, we have brought the example of monitoring a real geothermal source heat pump, which is a residential site in Belgium. So we have different colors for different bars. The green bars, they are representing the energy extracted from the geothermal field. So, and the yellow bars, they represent the electrical energy consumption of the heat pump compressor. And the red points on the top of the bars show the daily COP of the geothermal heat pump. So as you can see, we have evaluated these kind of parameters for different days in Belgium for residential site from end of January until the beginning of February for different days. For different consumption, for different demands, we have different values. As you can see on the right side, so the difference between the winter mode and the summer mode is like the heat delivered to the building from the heat pump is equal to compressor work plus heat from the ground or the air. So this is the winter mode, and vice versa. In summer mode, the summation of compressor work and heat from the building is equal to heat injected into the ground. And the last one is about the maintenance. So in maintenance, we have to consider two different sections, ground exchanger and mechanical room components. For the ground exchanger section, we have to monitor the system pressure and refill the installation if necessary to ensure the proper fluid circulation. So, and please remind it that check the antifreeze properties for for heating operation and replace every 10 years to maintenance efficiency and prevent freezing issues. For the second part, for mechanical room components, as you can see also the right picture, we have Valencia, our test site. It's one laboratory here, and it's like with high precision, and we are considered as European centers of excellence, the Western one. So for the maintenance of the equipment room, we have to follow the recommended maintenance protocols for heat pumps, heat exchangers, and control systems as outlined in the technical guide for thermal installation maintenance to ensure the optimal performance and durability of the shallow geothermal systems. Thank you for attention.